This is Geometry Semester 2's midterm review. We're going to start out with number 1, looking at what would have come from Unit 7, and we're going to figure out the missing side using Pythagorean theorem. Using Pythagorean theorem, that would be our hypotenuse squared equals the leg squared plus the leg squared. Remember, the hypotenuse is always across from the 90-degree right angle. The legs are your two sides that are perpendicular to each other. So in this case, the x is your hypotenuse. So x squared, 7 squared, and 11 squared. So x squared is going to be 49 and 121. So our x squared is going to be 170. And we take the square root of that. And 170 can be broken down. To break it down, it would be broken down by 2, 5, and 17, which none of those are perfect squares and none of those are repeats of each other. So that's actually our best answer. Leave answer in radical form. On this one, remember, a hypotenuse is across from the right angle. The legs are the perpendicular sides. So we're going to say 25 squared equals leg squared plus leg squared. It doesn't matter which leg you use. Another common way to say this is c squared equals a squared plus b squared. I typically stay away from that just so you don't have to get confused on what side's C and what side's A and B. 25 squared is 625. 16 squared is 256. So we'll take 625 and subtract our 256, and we come up with 369. And when we take the square root of that, we're going to get x equals the square root of 369. Now we can look at this and we can see that 3 would definitely go into each of those. So three times 123. And then 123 can be broken down also by 3. 3 goes into that 41 times. So there's your pair of the same numbers. So it's 3 square root of 41. Now we're looking at 3 numbers, and we have to determine, does it form a right triangle, an obtuse triangle, or an acute triangle? Remember, one test you always want to look at first are, do the two smaller sides add up to be greater than the third? That determines if those numbers could even make a triangle. And yes, 38 and 50 are bigger than 54. So first of all, it does make a triangle. Second of all, what size triangle does it make? So we take the largest side, squared, and we're going to compare that with the two other sides. So 54 squared is our 2,916, and we're going to compare that with 38 squared and our 50 squared. So when we add that number with our 1,444, this side is 2,916, this side is 3,944. C squared is less than the other two sides. So if C squared is less than, then it's an acute triangle. You always want to set it up in the format of C squared and compare that with A squared plus B squared. You don't want to write it in the opposite order. You need to put C squared first. Then it reads really easily. C squared less than means acute. C squared greater than would be obtuse. And C squared equal to would be a right triangle. So here the two smaller sides add up to be 14 and 19 add up to be 33. 14 plus 19 add up to be 33. The two smaller sides aren't even bigger than the third side. These sides do not make a triangle. So there's no need to determine what type of triangle it makes, since it doesn't even make a triangle. The two sides aren't long enough to come together to form our triangle. In other words, you have your 35, and then you have two other parts, one at 14 and one at 19, and they don't even make 35. They only make 33. So it doesn't make a TP type of triangle. Find the missing side length. So here we notice there could be a couple different formats we could use with this. Because they want us to do it in radical form, that kind of pushes us into using special right triangles. Pythagorean theorem here wouldn't work because we don't have enough information for all three sides. With special right triangles, this is a 45, 45, 90 triangle. So we know that the hypotenuse is going to equal the leg times root 2. Our hypotenuse is x. Our leg is 9 times root 2. So x is 9 root 2. You always multiply the leg by root 2 to make the hypotenuse. Now with this one, we see that the two legs are the same length. So if the two legs are the same length, we know that their two acute angles have to be the same measure, which are both going to be 45. So this is a 45, 45, 90 triangle. So if it's that, then we're going to use our formula of hypotenuse equals leg root 2. Our hypotenuse is 2 square root 6. The leg, we don't know its length, times root 2. So if we want to get dx by itself, we have to divide by the square root of 2. Square root of 2's cross out. Here they can reduce. So each leg would need to be a length of 2 root 3. I know that's not a common length for what we typically talk about, the leg lengths, but we're using our formula. We did our calculations correctly. The hypotenuse was a funny measurement of root 6, so that makes the leg a funny measurement. It's just the leg has to be root 2 times the leg. So root 2 times root 3 gives us that root 6. So that's how we got that measurement. Here's another special right triangle. This one's a 30, 60, 90 triangle. It has two different formulas to use. It has the hypotenuse equals the short leg times 2, and it also has a formula of the long leg equals the short leg times root 3. Notice how this radical was different than the radical we used up here. So you'll have to work on trying to keep that straight. The way I remember is that root 2 is because two angles are the same. Root 3 is because all three angles are different. 3 because it's like 30. So different ways that can help you remember how the formulas are written. So the short leg is always across from the smaller angle. So this is the short leg. The hypotenuse is always across from the 90. And the long leg is always across from the larger angle, 60. The largest angle across from it is, of course, the hypotenuse. But across from the 60 is the long leg. So we're looking for the long leg, so we're going to use this second formula. The long leg is our x. The short leg is 7 root 3. And then we're going to times that by root 3. So when we multiply two radicals that are the same, you get what's inside. You could call it the square root of 9, which is 3. So 21 is the length of our side. Here we also have a 30, 60, 90 triangle. This time we're looking for the hypotenuse. So we're going to use the hypotenuse formula. So your hypotenuse is your unknown. Your short leg is apparently 13 times 2. That's telling us that the hypotenuse is always twice the size of the shorter leg in a 30, 60, 90 triangle. Now we look down here, and this is not a special right triangle. This is not 30, 60, 90. This is not 45, 45, 90. So we can't use either one of those rules. Okay, we're going to need to use trigonometry. And the way we remember our trig ratios is to use SOHCAHTOA. SOHCAHTOA gives us the letters that help us remember how to write our equation out. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So if you look here, we know that across from the 90, of course, is the hypotenuse. Across from the 72 is the other side that we're looking at, the opposite side. And then just for practice, the side next to the 72, the one that makes part of the 72, is considered the adjacent side. So we're going to use the opposite and the hypotenuse. So which trig function would we use that deals with the opposite side and the hypotenuse side? Sine deals with opposite over hypotenuse. Cosine deals with adjacent over hypotenuse. Tangent deals with opposite and adjacent. So opposite, hypotenuse, there was only one that dealt with those. So sine of our angle equals the opposite side over the hypotenuse. We place this over 1 and we cross multiply. That gets us x times the sine of 72 equals 8. Then we'll divide by the sine of 72. Okay, we need to be sure we're in degree mode. Most scientific calculators will be automatically in degree mode. The graphing calculators will default to radian mode. So one way, looking at your calculator to see which one you have, if you use a graphing calculator, you hit you hit mode, and you'll see that the degree is highlighted. Another way for you to test it is to hit sine of 30. And we know that the sine of 30 should give us a ratio of 0.5. So that's a real easy way for you to identify which trig, which angle versions that you're using. So 8 divided by the sine of 72. That's going to give us 8.41. Round to the nearest hundredth, so we look at the third number and we see that that number is not 5 or bigger, so we're not going to do anything to the hundredth spot. Okay, here we have a right triangle. You got to have a right triangle to use trigonometry. We see that this is not a 30, 60, 90 or a 45, 45, 90, so it's not a special right triangle. We can't use those methods, so we're going to have to use trigonometry again. So our SOHCAHTOA will help us determine which trig function we're going to use. Let's look at what sides we're dealing with. Across from the 90 degrees is the hypotenuse. Across from the 15 is the opposite side. It doesn't look like we're using that at all. And next to the 15 is the adjacent side. So which trig function are we going to use that deals with the adjacent and the hypotenuse? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite and adjacent. So notice that cosine deals with the adjacent and the hypotenuse. Those are the two sides that we're working with. So cosine of 15 equals x over 50. Place that over 1, cross multiply, so we get 50 times the cosine of 15. Now notice that there's no need to divide away any numbers here. That's why you want to show your work. You want to do your cross multiplying and then see what happens. So 50 times the cosine of 15. That comes out to be 48.30, because the third number is 5 or bigger. Therefore, it rounds up the next number, which is a 9, which turns it into a 0 and rounds up the next number. So 4830. 4830. On the next page, we're looking to solve a right triangle. When we use the word solve a right triangle, we're supposed to be finding all the missing sides and angles. So we know angle K because it's a right triangle. We know angle L, 62.3. So we'll be looking for the measurement of angle J. We'll also be looking for the side LK. And the other side we don't know is side LJ, JL. So we're going to have to solve for all three of those parts. So to find the angle, we know that the acute angles of a right triangle are always complementary. So we know that the measure of angle J plus the measure of angle L is going to add up to be 90. So the measure of angle J plus 62.3, we subtract 62.3, so if we take 90 and minus 62.3, we're going to get the measure of angle J to be 27.7. Those are degrees. Now we need to find the other two side lengths. We could write 27.7. I typically like to circle the answer to show the value that I calculated. So this again is not a 30, 60, 90 triangle. It's close to 60 but not quite 60. So therefore we can't use those special ways, the special right triangles. We're going to have to use trigonometry again. So I'll write out my trig functions with SOHCAHTOA. Notice that across from the right angle is always your hypotenuse. Here's your acute angle that we'll use. Always like to use the number they give you. Across from that is the opposite side, and next to that is the adjacent side. So we could solve for either one of these. Here I have LK, so let's find LK first. So using LK, I know I'm going from the 62.3. The numbers that I know about are the 9. I have to use the 9 because I got to have some side length that I know about. And I'm also going to solve for the adjacent. So I'm using the opposite and adjacent. This is opposite hypotenuse, adjacent hypotenuse. This one's opposite and adjacent. So I know that I'm going to use the tangent of 62.3, 9 over LK. So you cross multiply. So LK times tangent of 62.3 is going to equal 9. Now in this one we have to divide by the tangent of 62.3 because I want to get my LK by itself. So using our calculator, we take 9 divided by the tangent of 62.3. That comes out to be 4.73. Now notice, if this is 62, we know the other angle was 27. Across from a smaller angle is going to be a smaller side. So we knew that this side had to be less than 9. And because the angle is more than half as small, we know that the side is going to be more than half as small. Okay? So that is 4.73. And then to find the last side, running out of room here a little bit, you could use Pythagorean theorem at this point, but trigonometry works great, especially if we don't have to use that 4.73. We can probably stay away from that using opposite and hypotenuse. So sine of 62.3 equals the opposite over our hypotenuse, and we will cross multiply and get JL times the sine of 62.3 equals 9. I'm now going to divide 9 divided by the sine of 62.3, and that'll come out to be 10.16. Notice that the hypotenuse is going to be the longest side. We'll come over to this triangle and recognize that we don't know the measurement of angle P. We don't know the measurement of angle N. That makes it a little trickier for us. And we don't know the length of the hypotenuse, which is PN. We know the 90 degree and we know the two leg lengths. So, we could use Pythagorean theorem right away to figure out the missing side. We could go ahead and try to find the angles. Let's look at the angles real quick. We have to decide which acute angle we want to find first. Let's find angle P. Notice that across from angle P is the opposite side. It's always considered opposite to be across from it. Next to the P is the adjacent side. And of course, across from the 90 would be considered your hypotenuse. So we're going to be working with the 12 and the 7, the opposite and the adjacent. So we're going to use tangent. Tangent of this angle, but I don't know what the angle is, so I'll just write in P equals the opposite over the adjacent. Notice that when you have 12 over 7, you don't have anything to solve there, so there's really no need to cross multiply. But what we need to do is to get the P all by itself. So to do that, we're going to take the tangent inverse, and that essentially brings the tangent over to this side. So the measurement of angle P is going to be the tangent inverse of 12 divided by 7. So how you do that with your calculator, you hit second, hit the tangent button, and that gives you your -1. Put in your 12 divided by 7. You have to have parentheses around this value. So if your calculator doesn't automatically put parentheses there, you need to. You won't get the right answer. So this should be 59.74 degrees. An easy way to help us figure out the value of angle N is to say that 90 minus 59.74 is going to be 30.26. And then to calculate the last side, we could use Pythagorean theorem, or you could use trigonometry. It's your choice which method you would like to use. Sine, well, let's see. Instead of using an angle that I found, I typically like to stay away from that. Because if that's not right, then I'm guaranteeing that this is wrong. And because that's just an approximation, again, it's not a great number to use. So let's use Pythagorean theorem. Hypotenuse squared equals leg squared plus leg squared. So we have Pn squared equals 7 squared plus 12 squared. Pn squared equals 49 plus 144. That gives us 189. No, actually 193. So if we take our 7 squared and our 12 squared, we're going to get 193. And when we take the square root of that answer, we're going to get 13.89. And that's approximately 13.89. Find the other video for the rest of the review.